Okay, welcome to this week's Megaport Live Tech Drop-In session. This week, the topic we're going to be looking at is Megaport Cloud Router, or MCR. We'll go through a couple of the usual bits at the start, just a really kind of quick overview of Megaport and network as a service, and then we'll jump into the Cloud Router specifics. So we'll have a look at what it does and what the features are and what the architectures look like, and also some of the common use cases that we see. And then we'll jump into a demo, run through how you can deploy it in the portal, and then we'll do a Q&A at the end. So Megaport in general and network as a service, essentially what we do is we have this large private network that we've built around the world that connects to a bunch of interesting places that customers might want to connect to. Customers connect around the edge of that network and can bring up dynamic connectivity over that private fabric to wherever they might need to go. So oftentimes that's connecting into a cloud to cloud provider. All the different hyperscalers, we've got connectivity built out to a bunch of different interesting service providers, but also it's used for internal connectivity. So customers can connect between their own data centers or between other customers. So for B2B type connectivity as well. So there's a whole bunch of use cases. Really, the idea is that we try to provide a sort of cloud-like experience for those network resources. So contrary to a traditional telco type of setup, it's much more aligned with the cloud provider model, where you have an account and then you can log in at any time to the portal. You can create resources whenever you need. You can modify them and change sizes. You can take stuff up and down, and you have control over all those resources, and they're available and ready whenever you are. So what is MCR? Megaport Cloud Router, or MCR, is basically it's a routing instance deployed into a Megaport point of presence. So it's on Megaport hardware in the data centers that we're in. So we've got access to something like 850 data centers around the world. Megaport's deployed into some of those physical locations onto Megaport equipment, and you spin up an instance of this router on those devices on that platform. So it's really designed to be as easy and automated as possible. It's designed to be really pretty hands-off. You definitely don't need to be a network engineer to deploy and configure MCR. There's very minimal as far as ongoing management or anything like that. It's really designed to be as simple as possible, as easy as possible, and as quick as possible to deploy. There's a bunch of options for architecture. So you can deploy MCR in high availability configurations. You can deploy it across locations for geographic diversity. You can build out global architectures with MCR. It's often used to route between clouds, but not only to route between clouds. That's something that comes up a little bit, I guess, because of the name. It can be used to route between anything on Megaport's network, not just cloud providers. So a lot of customers use it to route between clouds. Some customers also use it to route between data centers or other locations. Some customers connect together multiple MCRs to build out network architectures within Megaport's environment to sort of facilitate global deployments if they've got resources in different locations. So there's all kinds of use cases. You can really use MCR to route between VXCs. That's kind of the idea. So wherever those connections happen to go, whether it's a data center or a cloud or some other kind of service provider, you can sit MCR in the middle as a router to manage the layer 3 aspect of those connections. So all the management and deployment and everything is through the Megaport portal or API. You don't have to get involved in what's behind the scenes. You don't have to log into a CLI or anything. There's no other interface that you have to log in and manage. You don't have to kind of look after anything. You don't have to worry about the specifics or the instances or anything behind the scenes or firmware or anything like that. You click deploy in the Megaport portal and it spins up, and then all the other configuration is via the Megaport portal. And as with everything else, anything that's available in the portal is also available via the API. So it's totally possible to automate all of these deployments and configuration changes via the API, and that includes our Terraform provider. So the Terraform provider can also deploy MCR instances and configure all the details for those routers. As far as being a router, MCR supports BGP because that's typically that's the routing protocol that cloud providers use. It's probably the most common in this type of context. So it's really pretty seamless to bring up that connectivity into the different cloud providers and integrate with the CSPs edge products, because they also run BGP, and we try to automate as much of that workflow as possible. You can do some configuration of that routing. So we support AS path prepending, we support MED, we support some route filtering and bidirectional forwarding detection. So we try to provide as much as we can while also keeping the product as simple as possible and as easy as possible to use. So you do have a little bit of flexibility there if you want to do some more advanced configurations. So this is probably one of the most common architectures that we see, where you'll have 2 MCR instances deployed in geographically diverse locations that'll be used to route traffic between multiple cloud providers. Sometimes it's just 2, sometimes it's more than that. Often this architecture comes about because we'll have a customer who doesn't have any data center presence at all. They're just in the cloud. They're kind of either cloud native companies, or they've migrated entirely into the cloud and decommissioned all their data centers. But then they find that because they have multiple clouds, they need to orchestrate connectivity between, and they have no data center. They don't have any way to really, they don't have anywhere to link that back to. They don't have a stack of network hardware or something that they can bring these connections back to and use to bridge between these environments. So MCR can fit really well as a solution for that. You can have it sit between all of these cloud providers and connect to them using the physical connectivity that Megaport has in place to these cloud providers. So you're not routing the traffic over the internet. It's not VPNs or anything like that. It's physically on an appliance in a data center, and it's connecting via physical cables into these cloud providers directly to those resources. So via direct connect into AWS, via express route into Azure, fast connect into Oracle, and Google partner interconnect into GCP, and a bunch of other providers that we have access to. So you're getting access to the private connectivity methods of the cloud providers. You're getting the benefits of those methods, so all the SLAs and high bandwidth, high capacity, kind of enterprise grade connectivity. And then you're able to very seamlessly and very easily bridge that into the private connectivity service of another cloud provider. So you can connect these things to each other really, really quickly and easily, and get the enterprise level connectivity and SLAs and all the other bits and pieces that you might need. So this is another use case that we see pretty often for MCR. So in the event that you do have a data center, and maybe you do have some network equipment in that data center that you could use to connect to multiple different cloud providers and route the traffic between them, sometimes it's still not convenient to do so. So sometimes your data center or your network equipment might be not near where the clouds are, not near where the on-ramps are. So in Australia, we see this a lot with customers with data centers in maybe Brisbane or Perth or Adelaide, that kind of thing, whereas they'll have cloud regions usually in Sydney. It's possible to connect to all the different clouds from your DC in that city, but if you need to route traffic between those clouds, you probably want to avoid that traffic having to go all the way from, for example, Sydney to Perth back to Sydney to get from AWS to Azure. You also will find that those connections tend to be pretty expensive. So those long distance connections from somewhere, some city to some other city, tend to be reasonably expensive. So because you're paying for that intercapital bandwidth. And so if you do that individually, you have to do that 3 times or however many times for each different connection. You have to keep buying these connections across to wherever it is that these resources are. Whereas the other option would be, if you have MCR, you can deploy MCR in the location where these resources are. And it gives you the ability to route locally. So just for example, in Sydney, if these clouds are in Sydney, you can route locally inside of Sydney. Or if it's maybe Singapore, you can route locally inside of Singapore. You don't have to bring that traffic all the way back to your data center and then back to the cloud. You can deploy an MCR that sits right next to the cloud, right in the same physical facilities as the CSPs, and route really quickly locally between them and improve performance capacity. But you also sometimes reduce the cost, because now you're only buying one link from where the data center is to where the MCR is. You don't have to buy however many links you have cloud providers or you have resources. And they may not be cloud providers, as I mentioned before. They might be, maybe there's other data centers, maybe there's other types of service providers. It could be anything. But MCR gives you the ability to establish that routing presence wherever you want. So we have this available in a whole bunch of metros globally. So you can really quickly and easily establish the ability to route traffic locally in any metro where you might need it. So you can build this out quite a bit further. The examples before are pretty simple examples. They're quite common, but some customers obviously have larger requirements. They have more global requirements. They need to build out an architecture where they can do local routing in lots of points around the world, and they can build a global WAN across all those locations. So that's another use case for MCR, where you might deploy MCR into multiple cities around the world and then connect those MCRs to each other and build out a global backbone over Megaport's private infrastructure. So this gives you a fair amount of control over where you route things, and it gives you private paths between all of your locations and all kinds of different cloud environments, data centers, whatever else you might have. And it's really quick and easy to deploy, and it's very much built to exactly what you need. So if you need to be in a particular city, you can deploy into that city. You can choose the capacities you need, where you need them. You can change these things up and down. You can really build out something that fits exactly your use case, really, no matter how large that is. All right, so we'll jump into the portal and we'll do a quick demo. What we will build is something that looks somewhat like this bottom option here. So we'll deploy a port into a DC, we'll deploy an MCR, and then we'll build a connection from the MCR off to AWS and Azure, and see what that looks like. Basically see how easy the process is. All right. So this is the Megaport portal. So the first thing that we'll do, we'll jump into the services tab here. We'll create a port. This is not necessarily required when you deploy MCR, as per the diagrams earlier. You don't need a port. You don't need any DC presence to deploy MCR. That's fine, but sometimes you do, right? If you need to connect it to a data center, you can use a port to do that. It's really about trying to match exactly what your requirements are and deploying only the resources that you need. So we'll deploy into maybe 5G networks, just for example. So this is the list of data centers that we have available just in Sydney. We'll choose a speed for the port, get a name, and we'll order that service. So that's basically the process to order a port into a data center if you do need to physically connect in a DC. Next, we'll order the MCR itself. So again, we will deploy this in Sydney. We'll choose maybe, let's say Macquarie. We'll choose 1 gig for the MCR. So you can choose the capacity that you need, the routing capacity for this instance here. Let's call this MCR1. You can choose the AS number that you want to use for the MCR. This is a Megaport-owned AS number that you can use. Some customers will keep that AS because it gives you some options around public connectivity and peering. If you want to do public cloud peering and use Megaport IP addresses, you can do that. We have a workflow for that. Otherwise, a lot of customers will use a private AS number here. So something like that, to, if they don't plan on connecting any public interfaces or public IPs or anything to this, or doing public peering. So we'll try that one. We'll go add MCR and order. Okay, so the first port that we deployed in the data center is ready to go. So that's basically ready to be cross-connected into the customer rack. You can download the LOA here to see where the demarcation point is and order that cross-connect. The MCR is deploying now. So basically what we'll do from here is add connections to the cloud providers and add a connection back to the port in the data center. So what we'll do first is we'll go add a connection, and we want to do a private VXC. We want to connect to the data center that we deployed into, and we'll give this a name. We'll choose the speed for this VXC, so we can do 1 gig per second, and we'll leave everything else as automatic. Here we can provide the IP address for this interface. So on the route, on the MCR, because it's a router, each of these VXCs will map to an interface of that router. So each of these VXCs will have an IP address on it, and that's where the layer 3 terminates on the MCR. So we'll do maybe this for this interface. And this is where we would configure the BGP as well. So in this section, we'd configure the BGP for this VXC that goes back to the data center. So this would be a BGP session between the MCR and the hardware that's in the DC. I'm going to add VXC and order. All right. So you can see that MCR is actually all up and running and ready to go now as well. You can see the status there of the service is up. The status of this port here is configured, and that's because obviously we've just ordered that port and there's nothing physically plugged into it. So the switch port itself is not up yet and won't come up until there's a cable plugged in the DC. The MCR though, because it's entirely virtual, it's all up and running and ready to go. So the next thing that we'll do is add a connection to the cloud. So we will connect to AWS. We'll choose hosted VIF, and we want to connect to AWS in Australia. Okay, so let's call this AWS VXC. And let's say we want to have maybe 200 meg of connectivity into AWS. Go next. So as I mentioned, we try to make this as easy and automated as possible. So basically, MCR will automate the configuration of this whole thing. We'll provide it the account ID. So this is the ID of the AWS account that we want to connect into. We'll provide it the AS number on the AWS side. So this will match your virtual gateway in AWS. We'll provide the customer IP. So let's say that, and we'll provide the AWS side IP, which will be like that. Go next and add VXC and order. So you can queue these things up as well. If you're going to order multiple services all in one go, you can just run through the workflow, order them all, and they'll go into the cart on the left-hand side, and then you can hit order now just the once and order the whole lot in one go. So the last part here, we will jump in and add a connection to the cloud again, and this time we'll choose Azure. With Azure, the workflow is a little different. So firstly, what we'll do is if we jump over here to the Azure portal, we'll have this express route circuit created. So step one with Azure is jump in the Azure portal and create an express route circuit. So that circuit's already here and being created. Once that circuit's created, you'll see that there's a service key here. So we'll copy that service key, and then we'll go back to the Megaport portal. We'll paste that service key in. And basically what this does is it looks up that service key on the Microsoft side and checks where that ExpressRoute service exists. So this ExpressRoute service exists in Equinix and Global Switch. It can map it through to the right port and the right device on the Microsoft side. So we'll choose to connect to the primary one here because that's the zone out that our MCR's in. Here you can see this one's in the red zone. So we'll connect to this port in the red zone. Go next. Okay, and we'll give this a name. Let's call this Azure VXC. The rate limit here is automatically pulled from the Microsoft side, so we'll check on the Microsoft side what the speed is of that ExpressRoute service that was provisioned, and we'll automatically match that here. Go next. So the configuration will be generated automatically. So again, we don't really have to configure anything here. All the IPs and BGP and everything will be just automatically set up. And we'll hit order now. So what we've built now is basically what was in that diagram. So we've got a port in the data center that we can physically run a cross connect into to connect our rack in the DC. We've got a virtual cross connect from that port into the MCR. So that's one interface of the router. We've got another VXC from the MCR to AWS, which is another interface on that router. And then we've got another VXC from the MCR to Azure, which is a third interface. So we now have the MCR sitting in the middle of the DC and Azure and AWS, running BGP in all three directions and routing traffic between all those locations. So it's pretty straightforward. It's pretty easy. Like that took us 10 minutes or so, a bit under 10 minutes to deploy this whole thing. This is a real live portal. These are all deploying real live resources. So this is how long it takes in production to build out this whole private network. Okay, so next section's Q&A. So if anyone's got any questions, feel free to drop them in the Q&A panel. We'll try to answer a couple. We've got a few minutes left, so I'll answer a couple of questions. Let me have a look. All right. So first question is can the size be changed? Can the speed of the, all right, okay. Okay, so the first question, if we jump back to the Megaport portal, so you can see here that this MCR is 1 gig per second. So we chose that when we created the MCR. So as a part of this workflow, is a part of this workflow. When we create the MCR, we can choose the speed here in this list. So you can choose 1 gig, 2.5, 5, or 10 gig for the MCR, and that's the routing capacity of the MCR. So what happens sometimes, as you can imagine, is requirements will change over time, and you might need to change that speed up or down. The MCR itself can't be changed in place, but basically the workflow for that would be if we want to move this, like let's say we want to move from a 1 gig MCR to 2.5, we're in Macquarie here, so let's go create MCR, and we'll deploy in Sydney again, and let's choose the same DC as we're currently in. This time we'll choose 2.5 gig for the MCR, and let's call this bigger MCR. Okay, so we'll go next and add MCR. So we basically run through the same process. We deploy a new MCR of the size that we want. And then once that's deployed, I'll give that a minute or so to run through that process. But once that's deployed, you can use this button here to move connections. So what we would do is we'd hit move connections. We'd choose that we want to move all the connections from this original MCR, and we want to move them to this bigger MCR. And we say next, and move, and confirm. And basically what this will do is move all of those connections from the original MCR to the new one automatically. It'll move all of the config, all the interface config, all the BGP config, all those other bits and pieces will just automatically switch over to the new MCR. So you don't have to go and recreate these things on the cloud side. You don't have to change anything on the cloud side. You don't have to create new express routes, new direct connects. You don't have to change any config or IP addresses or anything. You just click the button. So you can see all those connections have moved to the new bigger MCR. And now there's nothing connected to the original 1 gig MCR. So we can delete that MCR. And now we've just got the new bigger one. So that's basically how you would shift between sizes. You can obviously do that to change up in size or down in size, or to move to a different DC, for example, or however you want to rearrange things. You can do that really quickly and easily. So that's the answer, right? So you can't change it in place, but it's really, really easy to just shift to a new one that's the size that you're after. Okay. Let's see if there's any other questions. Right. Okay. So the next question is, can we support capacities over 10 gig per second? So as you would have seen in the deployment process here, the highest capacity you can currently deploy for an individual MCR is 10 gig per second. So most of the time when customers want to go above that, what will happen is we'll deploy multiple MCRs and then use ECMP to load balance traffic across those multiple MCRs, because that gives you high capacity. So you can deploy 10 gigs and get 20 gig, for example, but it also picks up more availability because you've got more paths available. So you're kind of making a more resilient, more redundant architecture at the same time as you're getting the additional capacity. That said, there are sometimes a use case for larger individual MCRs. If you do need something larger than 10 gig, feel free to reach out, and we can kind of talk through the options. Okay. Okay, let's see what else we've got. Question. Okay. All right. So there's another question here about the term option. So you would have maybe noticed that in the workflow here, when we create the MCR, you can basically choose the term. So you can put the resources on a 12, 24, or 36-month term, and you get discounts. Basically, the larger the term, the larger the discount. But you can choose no subscription as well. If you choose no subscription, then it's per minute billed. So you can deploy the MCR, bring up a bunch of connections, use it for a day or a week or however long you want, and then tear it down, and you'll get a bill for exactly the amount of time it existed. So per minute, basically granularity. So it's prorated to exactly when that existed. So you definitely can do this on demand. You can use it for short-term projects and things like that. But if you do know that it's going to be around for a while, you can choose to put it on a term, so you can lock in a particular rate and you can get some discounts on the services. But yes, in general, they're available on demand and permanent build. So you can do testing and temporary deployments and things like that. Okay. All right. We're at the end of the half hour, so we'll leave it there. That's all for this week. But yeah, thanks for attending. And if you've got any other questions, feel free to reach out. Feel free to either reach out via email or via our website. If you happen to watch this on YouTube later on, feel free to leave a comment. We'll try to keep an eye on that as well. And we'll see you next time.